Hi students, here are your notes for 4.2, and it's going to focus on theoretical probability. In the previous lesson, we briefly discussed empirical probability. And the difference between these two types of probability are the empirical is based on experiments, also known as trials. So one way to think about this is I ask you to flip a coin 4 times. There is a chance you could get all tails all 4 times, right? And if that happens, that's because you physically did the experiment, the trial. So that's why it will be empirical. Versus theoretical is based on the math. Or I like to think about it as based on the theory. So then it goes hand in hand. And what I mean by that is if I flip a coin 4 times, based on the math, because they're equally likely, right? You could either get a head or a tail. I really should get 2 heads and 2 tails, right? That's known as theoretical. I'm not doing the experiment. I'm just basing it off of how the math should work. Where subjective is based on an individual's opinion. Individual's opinion. And this is not great, okay? We want to steer clear of that. We really should be basing it on theoretical. Now, empirical, if we do enough trials, it should lead itself closer and closer and closer to the math that is proven to be true, okay? But if we just do 1 trial, maybe we won't see it exactly. If you have time, I really want to encourage you to watch the TED Talk at the end of these notes. It's really, really interesting, and it talks about how probability can be used in a way that really alters how we think and how we make decisions, and especially if it's incorrect. So really, it went by very fast when I was watching it. I really liked it. All right, some more vocab. Events and outcomes. The results of an experiment or an observation is known as an outcome. And a particular outcome is known as an event. A single outcome is known as a simple event. And a combination of outcomes is known as a compound event. We really won't be touching base on that so much, but just wanted to give you some more information. So what I mean by this is, if we look at example 1, you roll a die, you want to list all the outcomes. So here it is visually. If you had to do this by hand and you didn't have a visual, you would just list 1, 2, 3, 4, 5, 6. So what these are all known as are your outcomes. And if I just focus on 1, that's known as the event. Okay, now example 2 is going to be a little bit more complex because now you're tossing a fair coin 3 times, all right? And I want you to list all the possible outcomes. So one event could be, all right, you toss that coin and you get a head. Second toss, you get another head. And the third toss, you get another head. The second time I do it, okay, I'm only tossing it once, but these are just all the outcomes of just doing it 1 time. Or when I do it, I get a head the first time, a head the second time, and a tail. Or I could get a head, a tail, and a head. Or I could get a tail, and a head, and a head. So what I'm doing here is, because it's a very common mistake for us to miss some outcomes, or miss some events, I should say, is I'm just introducing, I did all heads, and then I'm introducing 1 T and changing its location, okay? Then I could possibly get a head. Now I'm going to introduce 2 tails, a tail and a tail. Or I could get a tail, a head, and a tail. Or I could get a tail, a head, and a tail, a head, and a head. Where did I go wrong here? I already have that one. Forgive me. So I want to do, let's get rid of this one. So I need 2 T's. So I'm going to do a tail, and a head. And then the last one is I could do a tail, and a tail. So you can kind of see why it can get somewhat confusing. So you have here 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So we're going to get into probability soon enough, but right now we're just focusing on listing the outcomes. So the sample space is also known as the set of all possible outcomes. So I could refer to what we just found in example 3 as a sample space, or I could say all possible outcomes. So the probability of an event, so let's get into that. That is saying the probability of an event is always a value between 0 and 1, where 0 means the event is impossible, can't happen, where 1 means the event is absolute, it is certain. So think about what I'm saying here is that this will be a decimal or a fraction that is less than or equal to 1. It just depends on how the problem's asked. Sometimes they want it as a decimal, sometimes they want it as a fraction, and sometimes they want it as a reduced fraction. But if you get a decimal or a fraction that is bigger than 1, you've done something wrong. You can only have something happen 100% of the time out of the possible outcomes. So it has to be between 0 and 1. Now, probabilities closer to 0 are unlikely. They're still possible, but they're just less likely, while probabilities closer to 1 are more likely, but not definite. So the last piece of vocab for this video is when the outcomes of the experiment are equally likely, we can calculate the probability of an event as the number of ways an event happens out of all possible outcomes. Maybe I'll say number of all possible outcomes. So what I mean by that mathematically is the probability of an event, so same notation we introduced last section. This is going to be number of ways event happens. And it's always divided by number of ways of all possible. Number of all possible outcomes. Okay, so let's put this to use in the next video.